Ladies and gentlemen, thank you very much for attending this session. I've got to give some preliminary details regarding health and safety, and then we'll crack on with some framing notes, and then we'll hand over to the excellent panel that we have here. So I've got to give some fire instructions. In the event that a fire alarm sounds, which will be a continuous alarm, please vacate the building via the nearest fire exit, which is almost certainly the front door. And then please, in doing so, do not collect your belongings, do not use the lifts, not that you need to do so in this case, and do not re-enter the building until authorized. The assembly point is the Duke of York steps. So turn right, there's this Nelson column-like thing that's not as tall. Apparently it's Duke of York at the top, and that's where you want to assemble going forward. So that's the fire alarm. In terms of first aid, please go to the front desk and they'll sort you out. Right, so that's sort of the prelims over. In terms of the event, this is the role, I think the open question that we've got is the role of marine carbon dioxide removal in UK net zero. So my name is Mark Workman. I work with a team with this Oxford-led consortium. It's George, Philippa, and Imi outside. And essentially, the Directorate Hub is a part of the government £100 million investment in developing research and development around the establishment, scaling, and realization of a greenhouse gas removal sector in the UK in order to offset those residual emissions that are incredibly hard to remove and, according to economic theory, are going to be cheaper to remove via carbon removal technologies than to actually mitigate directly. Now, what you'll all know, because you're all obviously highly knowledgeable in this space, is that the entire net zero policy in terms of the greenhouse gas removal are land-based. What's happening at the moment is that there is this nascent sector out there called marine-based carbon dioxide removal. And it's the role of the core hub in order to be able to think about these technologies, find out a bit more about them, and consider whether or not they should be introduced within the broader net zero UK policy. So the questions that we're going to get asked today are what role does marine CDR have in net zero? What do they look like? I think there is an information asymmetry there. And what are the components of governance that need to be considered? So on that, I will now hand you over to Helen, who will take over. Thanks very much indeed.
Brilliant. Thank you very much. And hello and welcome to everyone in the room, also to those online. It's really, I think this is an important topic to cover, and it's really good to see the engagement we've got here. And of course, to thank CORE and the Royal Society for hosting this event. So, and the audience online will be able to participate via Slido. We'll get to how those online and all of you in the room can do that in a second. So I'm Helen Charowski. I'm here to host things. My research is sort of adjacent to this, but not directly involved. I do air-sea gas transfer, and I will introduce you to our wonderful panel here in just a second. But I think before we get started on that, just to add to what Mark said, I think this is a really important thing to discuss, especially for the public. Just 3 years ago, almost no one, I think, was talking about marine carbon dioxide removal in a bigger way. Some people might have been, but now there are these huge companies, Microsoft, Stripe, Google, putting vast amounts of effort and money and turning a very, very bright spotlight on these techniques. And yet the public barely hears that it exists. When they do, they mostly hear from companies who have a financial interest in doing this. And I certainly find on the interviewing side of my job, it's becoming very difficult to find neutral experts who are not, attached to somebody with some kind of axe to grind in this area. And of course, they're legitimate experts, but for the public, we need to hear a sort of more rounded discussion. So I'm really excited that we're all doing this. So I'm assuming that most of you, just by show of hands, actually, sorry to those online, you won't be able to join in this bit, just by show of hands in the room, how many of you would say you think about marine CDR on a regular basis? A little handful, and you know what, they're mostly sitting at the back. We've got the awkward squad on the back row. And how many of you, and there is no judgment here, how many of you are here to learn about marine CDR because you feel you don't know very much about it? You know what, they're mostly sitting at the front. Very good. Okay, this is good. Okay, so just to get us started, I wanted to set out one thing, just because it sometimes causes some confusion. And I think it's one of the things that every time we talk about this area, we just need to clarify right at the start, which is the difference. I hate acronyms, right? 3-letter abbreviations, they're everywhere. But anyway, the difference between CDR and CCS. So most people in the public, when they talk about things like this, they talk about carbon capture and storage, which refers actually to capturing emissions at a chimney where they're nice and easy to capture and then doing something with them. But carbon dioxide removal is about removing carbon from the broader environment. So carbon dioxide removal gets referred to as CDR, and often in this space, marine CDR is referred to as MCDR. I'm really, really sorry. We will keep the acronyms to a minimum. So our topic for the evening is that there's this idea of manipulating the ocean to get it to take up extra carbon dioxide from the atmosphere, which is where it's causing problems. Also causes problems in the ocean. But anyway, we will discuss that. So you heard the questions. What do we need to know about this? What do policy makers need to know about this? What is the public perception of things like this? How do we have a public debate wisely, well or badly? And really, what are the questions that we in society, both as interested members of the public and as policymakers, what are the questions we need to be asking as the debate about this intensifies? So let's meet our panel of experts here who have plenty more to say about this than me. So first of all, at this end, we've got Professor Ralph Rayner, who's affiliated with the Grantham Research Institute on Climate Change and the Environment, and also NOAA in the US, and has worked on marine CDR evaluation in association with the US Inflation Reduction Act, which has had quite a big effect in this area, especially over there. Next up, we've got Dr. Chris Pearce, who is a marine principal geoscientist at the National Oceanographic Centre, part of the University of Southampton, whose academic research looks at one of the proposed CDR techniques, enhanced rock weathering, which we will hear a little bit about. Next along here, we've got Professor Ros Rickaby, who is the Chair of Geology in the Department of Earth Sciences at the University of Oxford, and who's got a very good picture of the chemistry of the ocean and what the broader view, what the broader impacts on the ocean are. And last but not least, down the far end, we've got Dr. Elspeth Spence, who's a research associate at Cardiff University, whose research looks at the public perceptions of climate risks. So here is how all of this is going to work. We'll start by hearing very briefly from each of our panelists on their thoughts on this topic, setting out some of the basics and what they think we should be talking about. We'll then have a discussion here on stage for 20 minutes or so, rounding things out, filling out some of the gaps, perhaps asking some of the hard questions. And then the last half hour will be a debate, a discussion. We're inviting questions from the audience, both online and in person. And if you want to ask questions, there's two ways to do it. If you like thinking about these things as we're going along, can we have the Slido slide? So the wonders of Slido, if you've not used Slido, it's a very easy app to use on your phone. If you go to slido.com, what you will see is a page, and it'll say all it has is a single box. And if you enter that thing into the box, you can probably also do it by just pointing your phone at that QR code. You will be able to go to a sort of list of questions or list of a place where you can put questions. And the great thing about Slido is that not only can you input your own questions, either anonymously or with your name, but you can upvote other people's questions that you think are very interesting. So when it comes to the questions at the end, we will be looking at Slido. I have just realized I forgot to bring my iPad in here. So if anybody from the organizing group would like to go to my bag next door and get my iPad out of the grey thing in my bag, that would be amazing. So we'll be able to see your questions, but also in the room we will have a microphone going around, and you'll be able to do it the old-fashioned way. And if you're online, Slido is obviously your option. And to be very clear, what we would like is for your questions to draw out the expertise of our panelists. So I'm very keen on short questions and no commentary at all. Please, thank you. Okay, so let's get started. And first of all, we're going to hear for Ralph setting out the case for marine CDR.
Good evening, ladies and gentlemen. So I'm going to set a very high-level view, really to pitch for the rest of the panel here to follow with more detail. So there's pretty general agreement that we are in the Anthropocene epoch. That's an as yet not quite official unit of geologic time, describing the most recent period in Earth's history when human activity started to have a significant impact on the planet's climate and ecosystems. There's also a widely held position that our collective impact on climate and large-scale biodiversity loss have the potential to be existential for civilization, on a par with a major asteroid strike or nuclear war in terms of posing a risk of societal collapse. Last week, at an event to mark the 15th anniversary of the two Grantham Institutes, an esteemed panel of leading climate scientists and economists indicated that we remain on a trajectory where a civilization-ending outcome to the climate crisis remains a real risk. This echoes similar calls of alarm to this effect, such as the recent "humanity has opened the gates to hell" comment from the UN Secretary General. Yet we frequently treat climate change as a similar class of problem to, say, ocean plastics, failing to recognize that as a potentially existential threat, it requires a very different kind of response, more akin to the much greater urgency of the COVID pandemic, or perhaps a war. There's a need for much greater urgency and commitment of resources to reduce or eliminate the risk of a catastrophic outcome. First and foremost is the need to eliminate greenhouse gas emissions to the atmosphere. In its last report, the Intergovernmental Panel on Climate Change recognized that meeting a 2050 target for delivery of net zero cannot be achieved without large-scale removal of greenhouse gases from the atmosphere. Similarly, the International Energy Agency has recognized that net zero cannot be achieved in sufficient time to meet the 1.5-degree Paris target unless it includes large-scale carbon dioxide removal and long-term sequestration. What is less frequently talked about is that achieving net zero is by no means the end of the climate crisis. Assuming net zero is achieved by 2050, greenhouse gas concentrations in the atmosphere and excess heat in the ocean will be at a level that will continue to have enormous impacts in terms of heat waves, droughts, extreme weather, and rising sea levels. At net zero emissions, the risk of anthropogenic climate change remaining an existential threat may have been eliminated, but continuing very large economic, societal, and environmental consequences of high greenhouse gas concentrations in the atmosphere will remain. To truly address the climate crisis, we will need to go beyond net zero, and the only way to do this is by actively removing greenhouse gases, and especially carbon dioxide, from the atmosphere. If we're to be able to do this at a scale that is sufficient, we need to put much more effort into evaluating the least worst options for doing so. All options will have some measure of adverse consequences. We need to be able to make informed decisions about the playoffs between these consequences and avoiding or reducing some of the worst impacts of a changed climate. Most of the excess carbon dioxide in the atmosphere will eventually, after many thousands of years, find its way into long-term sequestration in the enormous carbon reservoir represented by the ocean. It seems intuitively obvious that we should at least properly evaluate the potential for enhanced natural and engineered means of accelerating this process as part of a delivery of net zero and beyond. With its world-class science and ocean science and technology expertise base, and with the 5th largest exclusive economic zone of nearly 7 million square kilometers of ocean, the UK should be well positioned to play a major role in the evaluation of the potential of marine carbon dioxide removal. It is my contention that proper consideration of this potential should have a prominent place in the range of options to be evaluated as contributions to meeting the goal of the UK Climate Change Act, and in turn, the wider global efforts to avert the climate crisis. Thank you.
Brilliant, great. Thanks for starting us off. Chris.
Yeah, thank you. Good evening, everyone. So I'm just going to start by echoing a point there made by Ralph, that carbon dioxide in itself, whether terrestrial or marine, is not the answer. We need to start by reducing global greenhouse gas emissions. We have to start every conversation with that, because without it, we're going to get nowhere. Secondly, why the oceans? Why are we looking to the marine spaces? Well, the oceans are actually one of the largest, or the largest carbon reservoir on the planet. They've already uptaken about 25 or over 25% of human CO2 emissions since the Industrial Revolution. So they're highly efficient at extracting carbon dioxide from the atmosphere. So they're already working as a carbon dioxide removal mechanism. Why are we considering this in terms of the UK's net zero strategy? Well, Ralph just emphasized the fact that we actually have over 7 million or nearly 7 million square kilometers of extended economic zone or EZ in marine UK territorial waters, and that includes our overseas territories, by the way. That is over nearly 30 times larger than the UK landmass itself. So if you think our GGR strategy is already only focusing on the UK land, we could already multiply that effectiveness by 30, just looking at our marine spaces that we have direct access to. And if you add in international waters or the high seas, that cover 50% of the planet. So people talk about 70% of the Earth's surface being covered by the oceans. That's true, but of course, a lot of that is within territorial waters. So as the UK, we have potentially access to 50% of the global waters, and that would increase our GGR capabilities by over 1,000-fold relative to the UK itself. So there's huge, huge, huge potential to use oceans to help support our carbon dioxide removal strategies. So magically above my head are going to appear some of the different mechanisms by which oceans have been proposed for using to actually encourage and support the removal of atmospheric carbon dioxide. This figure, for those who perhaps can't see it online, is taken from a report published by Ocean Visions just last week. So it's highly relevant, highly topical. And this is a part of their high-level roadmap to prove or disprove ocean-based carbon dioxide removal strategies by 2030. And you can easily access that by the link that's shown in the corner of the image. I don't have time tonight to talk you through all the different approaches, so but I'm going to try and give you a little concept about what the key concept mechanisms are, just to sort of help contextualize the discussion a little bit. So at the bottom of this figure, you can see there's sort of mainly biological approaches. This includes the blue carbon, mangroves, seagrasses, or coastal vegetation systems, which we tend to refer as blue carbon, though we could discuss that whether blue carbon actually refers to all ocean use of carbon dioxide carbon removal. There's also a microalgae, I think in the middle above my head, which basically looks primarily at the addition of nutrients, whether that's iron or other biolimiting nutrients to increase and stimulate the bloom of phytoplankton, and also macroalgae in kelp or seaweed growth. In all cases, these biological approaches absorb carbon dioxide from seawater through photosynthesis, so it's plant growth. And then what they seek to then do is to isolate that carbon from the exchangeable reservoirs, so it can't then be degraded, respired, eaten, pooed, released back to the atmosphere, where it then goes back and goes part of the continual cycle. So if you bury that photosynthetically captured carbon either in deep marine environments where it's very, very, very slowly degraded, or it's isolated from exchange with the atmosphere over thousands of years due to the Great Conveyor Belt system, then basically you're capturing that CO2 over humanly relevant timescales. The alternative approaches, which will sit at the top side of this figure, are more chemical or abiotic approaches. Perhaps one of the most commonly heard of is ocean alkalinity enhancement. And as its name suggests, this is really the inverse to what many of us relate to as an impact of global warming, which is ocean acidification. So whereas ocean acidification refers to the uptake of carbon dioxide into the oceans and decreasing pH, what we try to do is to increase the pH of seawater to offset that acidification process. In doing so, you give the oceans more capability to absorb carbon dioxide from the atmosphere. There's also electrochemical separation of seawater. What that does, it will strip out the carbon dioxide that's naturally contained within the seawater. It can then be captured and buried in geological reservoirs or used for other purposes, for construction materials and so forth. And then the CO2 depleted seawater can then be put back into the oceans. Right in the middle of the top panel is a deep carbon, deep ocean storage. And this kind of captures other aspects, which includes the use of marine spaces for CCS, which is, as Helen referred to, is really where we've extracted the CO2, whether at point source or by other means, it can then be put back down into geological reservoirs. But it also includes things like the injection of CO2-enriched seawater into basalt or the oceanic crust, where it may mineralize and capture over long timescales. And some people have also proposed such as to inject CO2-enriched fluids onto the seafloor itself. So there are quite a number of different approaches being presented for using the oceans in this manner, and all of these archetypal routes have various different twists and approaches, which we can perhaps get into later. I think what we need to consider is that all these different approaches have different effectivenesses. The efficacy is something we still need to better understand, and we also need to really understand what the impacts and different implications of these approaches are, both on the organisms and environments that they're being conducted in, but also in the human populations as well. And that's what my Ros and Elspeth will be talking about shortly. Thank
Brilliant.
you.
Great. Thank you very much, Chris. Okay, so let's hear a different perspective, perhaps a wider perspective from Ros.
Okay, hello, good evening. Thanks ever so much for giving us your time. So I'm a marine biogeochemist, and perhaps with the hat of paleoceanographer, where I've tried to understand the changing climate and indeed the changing carbon dioxide of the Earth over Earth's recent history. And Chris is absolutely right to say that the ocean holds a huge potential for absorbing CO2. As he said, it's taken up at least 25% of our emissions since we started about 200 years ago. If we go even deeper into time, we can see that the ocean actually took up about 7 times as much as that. But we think our best estimates are about 3,600 gigatons of carbon dioxide. An eye-watering amount of carbon dioxide was stored naturally in the ocean about 20,000 years ago. So the potential for the ocean to absorb CO2 is enormous. But what we can also learn from looking into the past is that should we manipulate the ocean to put CO2 into it, there could be consequences. And indeed, we can find evidence for that. So for a number of the suggested proposals up here, anything which boosts marine productivity or photosynthesis, where that organic matter is left in the ocean to degrade, will use up dissolved oxygen from the ocean. Now, you may well have heard that already the ocean is deoxygenating purely as a result of our warming of the ocean, which reduces the solubility of oxygen. And so what's known as ocean dead zones, we know have already expanded in the last 20 to 50 years. So any manipulation of ocean productivity will have the same impact unless we can put that organic carbon somewhere else. So I think that's an important point to remember for these biological techniques. We also heard about the idea of raising the alkalinity of the oceans. Again, the past gives us a little lesson in what happened during this time. We believe 20,000 years ago, the sea levels we know were much lower. And that means that places where coral reefs were growing were exposed, and we couldn't have coral reefs growing about 20,000 years ago. So all the limestone that was essentially going into those coral reefs was being added to the ocean. And that's in effect a mimic of this ocean alkalinity enhancement. Now, the impact of that was that all the tiny little planktonic organisms that make shells in the surface of the ocean made bigger shells and took that alkalinity out of the ocean. So again, a cautionary tale that we may well try to add alkalinity in its dissolved form to the ocean, but that could well have the impact that the ecosystem, where we've used carbon and dollars to move that alkalinity around and add it to the ocean, where the ecosystem will just absorb it for us and it will have no impact on net CO2 absorption into the ocean. So those are 2 little vignettes that we can learn from the past about this fact that should we put carbon into the ocean, there will almost certainly be consequences. Now, I don't want to say that I'm an absolute naysayer about marine carbon dioxide removal. We've certainly, discussing with Ralph earlier, we are on a time clock that is ticking. And we do need to find the winners and the losers, I would say, amongst this portfolio of opportunities. But I guess I would just appeal to scientists and to those working in social sciences and law, and try to at least identify the losers as quickly as possible and in a truthful way, where we say we can see red flags about either public acceptability, robust, we'll hear this term, MRV, monitoring, reporting, and verification. If I add some amount of nutrient to this ocean, how do I measure the impact on the carbon dioxide in the ocean? And can I really do that in a way that I can sell a carbon credit? And those sorts of questions, I think, are key to identifying the winners and the losers. The cost effectiveness, the efficiency, And for me, at least, the questionable impacts on the ecosystem are key. And if there are red flags, we should not create another disaster for the ocean and for humanity. So that's my pitch. We should make sure that every research pound is invested in the winners, and we should be quick to identify those winners and sort of progress with those.
Brilliant. Thank you very much, Roz. And then a different perspective again on the end there, Elspeth.
Yeah, so good evening. So my background is as an environmental psychologist. So we already know that people are really concerned about climate change. Even during the pandemic, with the cost of living crisis, that concern in climate change remains really high. And we've seen lots of impacts within the UK and also abroad. So people are concerned, they want solutions found to this. So in my background, I've looked at perceptions around ocean acidification and speaking to people about the oceans, particularly within the UK as an island-based nation. People are very attached to the ocean, so it's a place that people associate with positive emotions. A lot of people talking about going on holidays as children. Even if they live within cities, they still have this really positive emotional attachment to the ocean environment. So there's that already really positive associations with oceans. And then we're here talking about marine carbon dioxide removal. So we already know that people are really unfamiliar with carbon dioxide removal, never mind marine carbon dioxide removal. And it starts to get even more complicated when you start to think about categorizations and different terms, because as we've seen here, as Chris talked through, there's a whole range of different types of removal that could be conducted potentially, and they all have different risks, different benefits. So it gets very complicated when you're trying to think about engagements and communications and how things should be framed. So I was asked to think about how you would do this well or how you might do this badly. So there are plenty of examples from earlier work in public perceptions research looking at emerging risk issues. So I think when you're thinking about governance issues, there are plenty of questions that people should be asking as members of the public, policymakers, or funders as well. So as someone mentioned already, we should be thinking about how every pound is spent. And a lot of the time, funders now do want to have social science components within research, particularly when we're starting to think about things like carbon dioxide removal, but it shouldn't sort of be an add-on, it really should be central. And we should have proper funding to do that co-design that's required. So we should be thinking about questions like, who is involved in this project that's happening? Is it a scientific group? Is it funded by a commercial organization? You know, what are their motivations? Are locals allowed, are they involved in this study? Are they allowed to help monitor this project? Are people being open and transparent? And there's a real need for communities to have their concerns addressed. And if the trial is going ahead, or what controls are in place and how can it be stopped? Do people in communities or other stakeholders have space to do that? And as people have already mentioned, there's risks and benefits associated with each one. What are these for specific communities? And what are these more widely? So a lot of the ocean governance in place is quite global, but when it comes to marine CDR, we should be thinking at a more local scale for populations who are living in coasts, as also in a more broader scale as well. And the problem is there isn't really anything in place for people to think about how to conduct marine CDR research. So we need to start thinking about that, which is hence why we're having this conversation. And there have been a few reports recently looking at that. There's also the issue of justice issues. So how decisions are being made, who's being impacted by those, and then also who's going to benefit for these or who's going to be losers, so winners and losers, as you mentioned. There's a very social and economic impacts as well. So if communities are impacted by fishing being impacted, for instance. So there's a whole range of things. And there's also the issue of trust as well. So if you have commercial organizations who think, okay, this is great, I've got an ideal location to go and do this, but they go and do this without speaking to communities, for example, that can really lead to problems further on down the line. So there's a real sense that it's something for any engagement work, especially for these techniques, especially where there's some controversy, there's a need to be inclusive and transparent from the very start. So when you're thinking about siting and scoping, rather than sort of later on after you've maybe tested something small and you want to scale up. Because even if something looks like it's beneficial scientifically or for the community, if you've carried out something and not included people from the start, then we're going to have real trust issues and potentially opposition as well, even if it does look like it's something that could be beneficial. So really there's a consideration that you need to tailor whatever it is for that particular technique to that particular community. And each community is going to be unique, which is why it makes it very difficult. So from that, it's really just, I guess my message is to include the public from the very start. You can't apply a broad brush to it, and it's very unique. So I think we'll probably talk about that in more detail shortly. Thank you.
Brilliant. Thank you very much, Alistair. So be adding your questions to Slido if you're online, or if you're in the room, you can have that choice as well. Okay, so let's get started on some of the things. So I think every discussion of this should start with MRV, because if it doesn't work, there's no point. And this question of whether it works is complicated. You know, one of the, you know, as an ocean scientist, the thing that annoys me, one of my bees in my bonnet, is whenever anyone uses the word just in association with the ocean, because it's not a simple place. You don't just do anything. It's almost always more complicated than that. And in this case, you can do all this stuff in the ocean, but unless some carbon from the atmosphere goes into the ocean as a result, you haven't made any difference to anything. And of course, the ocean moves. It's not like you plant a tree and you can come back 20 years to check if your tree is there. The water moves around. It moves away from the surface. So I just wanted someone to give us a sense of where we are with MRV measurement. Sometimes it's measurement reporting and verification. Sometimes it's monitoring reporting and verification, depending on who you ask. And especially the concepts of additionality and durability, which come up a lot. You know, sort of these words. Would anyone like to start us off on how MRV is going to work? How are we going to know whether it works? Chris?
Yeah, I can start on that. So monitoring the oceans has been a challenge and a priority for oceanographers for decades now. It's something we're getting increasingly good at. We have the capabilities to go and make in situ measurements to the nth degree. You can get samples, bring them back to the labs, we can measure them in situ. We can do that throughout the depth and breadth of the oceans, and we can do it in space as well, using satellite remote-based observations. So we have the capabilities of technology to conduct these measurements. The question is, can we conduct them at the right precision required by regulators, required by the public, to actually give us a degree of confidence of when and where carbon dioxide removal is happening and what the impacts of that are. So actually, when we talk about MRV, we're looking at both the efficacy, the efficiency of carbon dioxide removal. Is the technique doing what it's proposing to do, and over the same timescales? And also, what are the impacts? So we need to monitor the effects on the ecosystems or the communities that near the site of being affected. You mentioned the durability, the permanence. You know, that's another big question when you're looking at alkalinity addition. We need to ensure that that alkalinity remains in contact with the atmosphere and the upper layers, the mixed layer of the ocean, to ensure that actually results in the uptake of carbon dioxide removal. Because if you add alkalinity and it gets subducted quite quickly to the deep oceans, we know from the great oceanic conveyor belt system that that deep water is not in contact with the atmosphere for thousands of years. So you're not going to see that exchange and draw down the atmosphere. So this is where our MRV approaches really need to focus. We need more research. You know, I keep going back to these answers, but we need to sort of really do more research to link together our in situ monitoring capabilities with our remote monitoring capabilities and our modeling capabilities to really sort of give us confidence, or the degree of confidence required by regulators, required by the companies, to sort of say that techniques are doing what they propose to be doing.
Brilliant. Any additions on MRV?
Only to add that the only way that we can effectively do that is by doing experiments at a scale that allow us to develop those techniques. So we're not going to develop them sitting in a laboratory somewhere. To actually answer that question, we have to do experiments in the ocean.
Go on, Ross.
I guess I am going to be a little bit negative here, because I think that if you add some chemical, be it a nutrient or alkalinity, to the ocean, however well you can measure the area around which you do that, and it is, you have to realize it's a diffuse environment. This stuff mixes incredibly quickly, which means that not only are you going to lose the signal of the thing that you've added to the ocean, but your ability to show that what you've added to the ocean has actually sequestered CO2, I think, is almost minimal. You may be able to do it with modeling, but your model then has to be incredibly high resolution, and it has to capture the chemistry. It has to capture chemistry in an interactive way with the biology. And I just don't think you can do it. My view is there may be techniques from the portfolio that we had, growing seaweed, for example. You know that you've added carbon to your seaweed. If you can harvest your plankton somehow in a sediment trap, you know you've got carbon, inorganic carbon. If you choose to perhaps remove, one of the great ideas is that the ocean has a CO2 absorbing capacity, which it does. So why not use that as opposed to a direct air capture, where you can then scrub the CO2 out of the ocean? Now, there may be cost implications for how you do that, but then you can measure the moles of CO2 that you are removing from the ocean. And again, so for my money, I would be putting it towards the things where we know that we can measure it. And as good as the model are, I think the revolution in sensors has been fantastic, but I still don't, I'm afraid, don't buy that we will be able to say, I added this mole of phosphate here, and I've absorbed that mole of carbon dioxide somewhere. And particularly if you've got multiple companies trying to do this in different places, how you attribute that. And to me, that should be a red flag that says we can't do it that way.
And I guess I'm supposed to be the impartial chair here, but as someone who measures the ocean and who works closely with colleagues who measure carbon dioxide going up and down, it's incredibly hard to do. It's incredibly hard to do it accurately, and to do it on this kind of scale. At the moment, we literally can't do it, although there are starting to be experiments that are going to try. So I think the level of, I guess the takeaway perhaps for policymakers here is that this is not simple. Showing it works is not simple. And people are working on models, that can do it well enough, but it's not a just thing, and it's not a casual thing. And we can't do it at the moment. Go on.
But isn't that's part and parcel of the ranking exercise that we need to go through to determine the order of merit, if you like, of different techniques, and decide where to place the investment.
Chris, did you have a quickly there?
Yeah, it's just, I agree, Ros. I do. But I think we also need to say, look, we need to understand what degree of precision is required. Because coming from a laboratory-based environment where we can measure anything to the nth degree, then that's absolutely true. We can't do that in an open ocean setting. But is that really required? Do marine spaces have to have the same degree of precision, the same degree of accuracy for regulators from a public perception perspective? I think that's what, I'm not saying we do, I'm not saying we don't, I'm saying we need to better understand what is capable and how that projects through. And Ralph's absolutely correct. We can only do that by starting to look at these techniques in natural environments. We could use natural analogs. It doesn't have to be in situ trials, but we need to start making these measurements from a CDR perspective in actual marine environments where you have that turbulence, where you have that mixing, and really then start to project that through to say, this is what's capable. Is that acceptable from the public's perspective, from regulators, from other stakeholders? Because only then can we say this can't be done to the extent you're asking for.
So I want to move on a little bit. We can come back to some of these things. So Elspeth, I think, if you sort of present this to quite a lot of the public now, my perception, you may want correct me on this, you're doing the research on it, is that the way people sort of see this on a simple thing is that, okay, you're telling me that we meddled a load of stuff, we meddled with natural systems and we made them worse, and you're telling me that meddling with something else is going to make it better. like there's this kind of like trust in, you know, we sort of messed up a natural system somehow, and now we're proposing to mess with something else to make it to, you know, like it's kind of sticking plasters on sticking plasters. And I think a lot of people would say, well, shouldn't we just stop the problem in the first place? How do we like, how do we present this to the public? I mean, because I think one thing we sort of get a lot in this space is that we see public perception as an obstacle. If they don't agree with us, they're wrong, and we need to persuade them to agree with us, rather than seeing it as, well, here's two people laying out two sides of an argument. We actually need to have a debate about it from a neutral point of view. Like, how do we do that with an issue this complicated?
Yeah, it's very difficult, I think, because there's a lot of science involved as well. So it's making that frame appropriate. So a lot of people talk about climate change as something that's already messing with nature, if you want to use that term. And then climate engineering, CDR, and marine CDR, these are all different ways of further messing with the environment. So you're right in your point there. You're kind of adding this messing with nature with messing with nature. And I would say I would tend to agree that people do think that you do sort of have different groups, I guess. You've got ones who think, well, perhaps the only way to get out of this is to further explore these systems. And then also those who say, you know, we've already caused damage and we should really look at other ways to do it. So I think for the publics, it's more an issue of time, because as soon as you start to talk about things like carbon dioxide removal or doing all these kind of techniques, it's always like, okay, but what about emissions reductions? Are we really in that space where we have to remove carbon dioxide and use these very technical approaches and use these systems? So yeah, it's a very difficult question to answer, I think.
I think that's true for all social science, isn't it? It's not just this question, but you know, we still have to address them. Okay, so I want to come to the question of costs and financing, because one of the things about this that is, you know, what has exploded in this space is the interest of companies, and companies exist to make a profit. And it's quite interesting. I mean, so the government, you know, the Inflation Reduction Act in America was a government intervention. I mean, it covered lots of things, but it had a specific allocation for CDR research to find out whether it can work, and 2 DAC plants, direct air capture, 4 DAC plants, direct air capture plants, which is a land-based thing. But apart from that kind of government intervention, we heard the UK government's given 100 million, was it, to this kind of thing. Like, how much is how do we deal with the sort of profit? How's the money of this work? Is it how expensive is it? Who pays for it? Are we biased by companies who want to kind of make a quick buck? We've all seen the disaster of offsets, you know, the offset, the trust in offsets kind of tanking, because it was shown that the process for verifying them was not robust, and that people were selling offsets that were worthless. So this all revolves around money. How does money interact with all of this, Ralph?
Okay, well, so first of all, I'm going to challenge you to stop characterizing all business as only motivated by money. Having been in business for most of my career, I can tell you personally that that's never been my primary motivation. I know many, many other people in business for whom that is not their primary motivation. In this space, I work with a number of small businesses working in this area, and I can tell you that the bulk of the individuals in those businesses are not driven by money. They're driven by doing something that's socially important. So let's now deal with the money issue. There are only 2 ways you can finance this. Either you're selling something to someone, and that in this space means you're selling a carbon offset of some form, or you're selling some product that arises out of conducting whatever carbon removal technique you're using. The second way that it can be financed is by direct intervention by government. And I think ultimately we're going to end up with both. You know, I come back to the timescale issue and the urgency issue. We've got 10 years to sort all of this out. If we don't move logically through a process of evaluating options, options will be chosen by the timescale. We'll do things that have potentially massive side effects because there is no choice. So we have got to work our way through this as best we can with both of those approaches to financing. If you're going to sell an offset, then clearly you've got to have some way of monitoring and verifying that that offset is viable and that it is sequestering or capturing carbon dioxide in the long term. Similarly, you're going to have to do that if you're directly intervening. But I think we are going to approach the point where direct intervention by governments is going to happen. You know, people are talking about solar engineering, and any of you that have read Ministry for the Future will see I can see exactly what happened in that book playing out. A nation will unilaterally decide to intervene in the climate system. We don't really want to be in that space, because that's completely uncontrolled.
Anyone else got anything to add? Yeah, Chris.
Yeah, just on the commercial perspective, and I agree fully with what Ralph just said. I just want to emphasize as well that all these techniques are based on scientific principles. They're not coming at this from a kind of completely wacky idea. These are natural systems, natural processes for the most part, that will basically being enhanced or looking at the potential to be enhanced. Companies are looking at this potential because there has not been direct government funding, particularly in marine CDR, we're really limited on how much money has gone in. To date, the US has been putting recently tens of millions of dollars into this. Germany as well, running projects. The EU, I'm fortunate to lead a Horizon Europe program called Strategies for Evaluating and Assessment of Ocean-Based Carbon Dioxide Removal. It's one of only a couple Horizon Europe programs looking at this space. There is very little funding for scientific research funding in the UK and in Europe to really sort of progress this. In an independent manner. So all of our knowledge is primarily coming through companies who have scientists and are very open at the minute to engagement. They're very open to having public talk to them. They're very open to having our scientific input to them. So, you know, although they are working at a space where they need to sell credits because that's their, you know, that's their mantra, but at the same time, they are doing it for the benefit, the broader benefit. So I agree that you shouldn't sort of take them all with the same brush, but it is equally absolutely fundamental that there are independent scientists who are evaluating, checking, and guiding their directions. And we're the ones, you know, we more broadly, not myself, but scientists need to help say what approaches are viable and what approaches aren't viable. And we are at the cusp of this. The amount of interest and the amount of companies operating in this space has, you know, tremendously grown in the last couple of years. It's only going to increase as people look towards their net zero pledges. And we need to be in a position, as Ralph said, when it comes to, well, before 2030, when the panic buttons get hit, you know, which they will do, because we're still on that trajectory, then we need to say these are approaches that can be put in place. Like these are ones we can look to here and now, and you know, be ready with the answers, which take time to understand.
Brilliant. So we will get to audience questions. There are loads on Slido already. Do add some more very, very quickly before we just get to questions, because I think it's an important framing point. Ros, in one of the conversations, in a conversation we had yesterday, there was a scaling thing you mentioned. Please just give us that, because I think this is really important.
Yes, I guess so. It was a point actually that I saw made by Richard Zeeby a few years ago, and he makes the argument, and I hesitate to use the word because everybody sort of fell off their chairs, but it's stoichiometric. So what I mean by that is, I've talked a bit about moles, which I hope hasn't scared you, but all I mean is an amount, and so let's say for ocean alkalinity enhancement. If we want to raise the alkalinity, make the oceans more basic to absorb more CO2, for every ton of CO2 you want to absorb into the ocean, you need to add a ton roughly of alkalinity, depending on quite the sort of alkalinity. So I was sort of trying to think, okay, well, let's just try and visualize that. So a ton of CO2, I was looking it up yesterday, I'm afraid, is about what you might emit in a petrol car for about 6 months. That's your sort of CO2 emission. In order to absorb that in the ocean, assuming it works effectively, and that's the big assumption. So as Chris said, it assumes that all the alkalinity is sitting in the surface, busy dissolving away and equilibrating and drawing all the CO2 down before it gets mixed out or sediments out. That requires sort of 4 wheelbarrows worth of the alkalinity stuff. So the point that I want to make is, certainly if you want to remove carbon by adding things to the ocean, it's almost in a 1-to-1 ratio. Now that means if you really want to fix the problem at a gigaton scale, you've got to shift gigatons of stuff into the ocean. And there is no multiplier here. It's not that you can put a ton in and you'll get 10 tons of CO2. It's essentially a 1-to-1 ratio, and that's if it works at your sort of maximum efficiency, which is unlikely. So it just, I guess for me, perhaps it was an interesting sort of little back of the envelope exercise that I think Tim Kruger, who might be in the audience, did, where he was sort of trying to say, well, how much would we have to raise global weathering rates? So how much stuff is coming down rivers to fix the problem? And you've got to raise global weathering rates 40 times every year. So the point that I'm trying to make is that the effort, and I accept Ralph's argument, which I'm sure he will come back with, which is we've got to find the least worst solution. But I just want people to realize the scale of the problem and the scale that might be required for some of these solutions to actually be effective. And it's almost like it's multiplying industry scales.
Very, very quickly, Ralph.
But we're not saying that we're only going to use one approach.
No, I accept.
You know, the essence of the solution to the climate crisis is a portfolio of approaches.
Yes.
We're also not saying that we haven't already trashed a lot of the ocean's capacity to take up carbon dioxide. So even if you'd have great public acceptance of the natural restoration end of this process, which is capable of yielding one of the little components of what needs to be done. This is about a portfolio of approaches over a short period of time. Well, back to we don't have time.
But
this debate could go on for a whole other hour, so I am going to cut you off. I'm very, very sorry to get to some of the audience questions here. So you can still, we will come to people in the room in a second. Let's have a look at some of the ones on Slido first. So the one that's been voted up to the top, which is a very interesting question. And I know you all have loads to say on all of these questions, so if you can be super, super brief, that would be amazing. And it is, are there any communities calling for marine CDR? Who wants it? Or this is what's written here, is it a climate solution without a constituency? So who wants CDR, marine CDR? Go on.
It's a good question, and I'm not aware of any community that necessarily wants CDR. I think if there are companies that have co-designed, so for example, there's a company, Project Festa, who looked at this in Costa Rica. Even though the project they didn't necessarily yield the results they wanted, the involvement of the community did sort of encourage the project ahead, and that engagement still goes on. But I wouldn't say there are communities that I'm aware of that are necessarily calling for it. I don't know what other panelists think.
Well, I think that there are many. I've been fortunate enough to work with islands, one developing states in both the Caribbean and Pacific Islands, and they are at the forefront of the issues of climate change. You know, they will become the world's first climate change refugees when their islands are flooded. So, you know, they have a very different perspective and engagement and relationship with the oceans than when many of us do, myself included, because, you know, they are fully dependent on it in terms of transport, livelihoods, you know, protein sources and everything. And that goes spiritually as well as, you know, socially. But I think, you know, they are already facing challenges, not just from sea level rise, but also desalinization. Sargassum in the Caribbean region is a huge issue. It's been increasing and rafting and causing deoxygenation as it rots in coastal environments. Sargassum is a seaweed. Potentially capturing that before it goes onto the beaches and burying it could be part of the solution. And I'm not saying it's the only solution, but there are circumstances where it could become part of the solution. And I think this is where, as Ralph said, we need to start to find portfolios. What areas start to work in conjunction with other aspects, and you know, this is the role we need to start playing.
So there's another question here, which is a little bit of a technical question, but I think it speaks to, there's a whole load of questions like this one. So this question is kind of representative of a lot of questions of a similar type, which are all because it's complicated. And this one is how quickly the ocean does its work. You know, when 1 ton of CO2 is removed from the ocean, how quickly is the same amount or some amount removed from the air, which we don't know the answer to, but I'm going to ask you all anyway.
Well, actually, I think we probably at least partly know the answer to that. There was a paper published quite recently, only about a month ago, that looked at exactly that question. How quickly does that process take place? And it was of order of months, as opposed to years. It obviously depends on which technique we're talking about here, but it was not as fast as directly capturing carbon dioxide from the atmosphere, obviously, because that's immediate, but it was still pretty quick in terms of equilibration.
Anything to add? We're all good on that?
Yeah, when you talk about ocean capture, basically the delay is getting the carbon dioxide, as you know, Helen, looking at that atmosphere to the ocean interchange. That's what we need to look at, and that's what causes the longest delays, and that is on the time frames of a month. Okay,
right. Let's take a question from the room. So if you've got a very short question, no commentary, please put your hand up, or if I've scared you too much by, have we got any hands up in the room? I will come back to you. Oh no, one at the back there. Yes.
Yeah, John Gibbons from UK CCSRC. Maybe you've already answered, but I don't think so. What about putting lime in the oceans? And I didn't quite get why animals making shells and having them sink to the bottom wasn't exactly what we wanted to have happen.
Okay, that's one for me. So adding lime to the ocean, if the organisms that make calcium carbonate in the ocean remove that lime, then you've done nothing. You've added alkalinity, and the shells have taken out that alkalinity. What you actually want is the alkalinity, or the lime, to remain dissolved in the ocean such that the ocean pH rises, which has the impact of pulling carbon dioxide into the ionic species, which are far more stable in the ocean.
But surely, no, come on. I mean, those shells have gone into limestone in the past, and there's gazillions of atmospheres of CO2 in limestone, and it's stayed there for a long time. I don't see why a shell sinking to the bottom, if it doesn't redissolve, hasn't taken up CO2.
Because it's taken the alkalinity. It's done is remove what you've added to the ocean. You were adding.
Yeah, but I added calcium oxide that I've taken out calcium carbonate.
Yes.
So a CO2 has gone into the calcium carbonate from somewhere, and it's come from the ocean or from the atmosphere.
So this comes back to how the carbonate chemistry works, essentially. So you're absolutely right that on a long time scale, that does act as a sink of CO2, but on a short time scale, the fact that you're removing the alkalinity from the ocean means that the pH of the ocean does not rise, and therefore does not absorb additional CO2 to the surface ocean.
I think one of the biggest challenges in this area is that carbonate chemistry is a pain in the backside for anyone who hasn't done at least 2 degrees in chemistry, because it's really counterintuitive.
Yes.
And you get these questions that sound very obvious, and you say that to a chemist and they go, they make the kind of face you just did.
Sorry.
But it's not wrong. And I think it's difficult because especially if we're having a public debate and we need to explain things in a way that, people can understand. This is one of those things which we really need to get right, because it is so counterintuitive.
Yeah. I just about to make that comment. It is this question of timescales. The dissolution of lime will create alkalinity, which has the potential to draw down atmospheric carbon dioxide. As soon as you precipitate the carbonate shells, whether that's in coccolithophores or coral reefs, then you negate that carbon dioxide removal because you're releasing CO2. So there is this question of timescales over which the time frame for the lime to dissolve versus the time frame for carbonates to be precipitated. And over human timescales, it's potentially the case that lime could dissolve, create the alkalinity, and absorb carbon dioxide, which we know would happen over timescales of months. But then the critters would start to use that alkalinity to precipitate their shells over decades, years. But we don't know. Yeah, we don't know those questions. We don't know those relative interplays. And that's why scientific research is critically needed in natural systems to really know what the response would be. If you add lime, are you going to cause a coccolithophore bloom, which is going to negate that? We don't know, because we don't know what interplay is between lime addition, alkalinity addition, nutrient addition, and the response to those natural ecosystems. That's where the scientific research has to catch up with the commercial proposals.
And we could do some simple experiments to answer that question.
So let's give everyone a rest from chemistry just for a second. It is very important, but one more question over there, yeah, and then we'll go back to Slido for a sec.
Sean Fitzgerald,
Please
University.
not on chemistry.
No, this is actually going to be certainly not on chemistry. I'm not a chemist. Sean Fitzgerald, University of Cambridge. I'm not a proponent of any particular approach. I am a proponent of furtherance of knowledge. But my question was about ocean iron fertilization. Controversial topic. The question is about the scaling, the gearing that we talked about, 1-to-1 ratio of a material that you have to move versus the impact on carbon dioxide removal. And so if you could just comment on what you think the gearing ratios might be for that particular approach, which I think might be different. And then secondly, related to ocean iron fertilization, we've spent many years moving from hunter-gatherer on the land to farming of the land, and yet we still just take from the oceans. Is there a role for tending to the oceans in some way rather than just take?
Okay, iron fertilization first. Who would like to comment on that?
Like
Ros.
I think you're right. If we look at the sort of ratio of iron to carbon, I forget quite what the ratio is, but it's certainly there's probably 3 orders of magnitude between the amount of iron that you get in a typical organic matter and the carbon that you have there. So yes, adding a small amount of iron will have a bigger impact on the carbon. What we know from, I guess, iron is a fantastic experiment in the sense that experiments have been done. People have looked at iron in the ocean, and at least to the best of my knowledge, there was no evidence of net carbon sequestration.
Okay, so let's go back to Slido for a second. So let's a nod to the policymakers in the audience, who are probably feeling that this is all very terribly complicated, and annoyingly so. What are some MRV frameworks that can be used in policy to ensure that research is efficient and not damaging? Like, how do we go about, what do policymakers, what questions do policymakers need to ask? What do they need to make sure in order to, I guess the question here is, what does a policymaker do faced with all of this? What do we do, right? Let's take that one instead, perhaps. What are your recommendations to policymakers who want to do a good job?
Communicate, I think, is a starting point. We need to get everyone in the room talking together. I made the point earlier when I was talking that we need to understand what the regulators need to see, and the regulators need to then define what is acceptable in terms of our monitoring capability. So we need to have those discussions in tandem, and this is something we're trying to deliver through the CO2CDR program, is to get everyone in the same room so we're all moving forward together, because otherwise there's a risk that policymakers will be expecting something that's not achievable in marine environments because of mixing, but could be achievable in land-based environments. So they need to be viewed in different ways because of the complexities. We also need to learn from examples. Helen, you mentioned at the start the difference between CDR and CCS. CCS has fantastic regulation, actually. Certainly here in the UK, is North Sea Transition Authority, NSTA, is really geared up in quite a good way to regulate the offshore injection of carbon dioxide removal. And we're starting to see the implementation of that in some of the UK sites, Northern Endurance Partnership and ACON and so forth. So I think we need to look to those in terms of the regulation frameworks. And there's also an increasingly attention being paid to governance frameworks in sort of the CDR space and public policy. It's this interplay between national and international governance is critical. The London Convention, London Protocol is probably the best we've got in the sector at the minute. They've already had an amendment in 2013 that governed iron fertilization, but they've just recently, a few weeks ago, made an addition to include macro algae and also ocean alkalinity enhancement. So there are some amendments in that space, but we need to sort of be more closely working with the bodies who are signed up to the London Convention, London Protocol, to advance the ability of that to respond to this rapidly developing space.
And just very briefly, for those who are not familiar with these things, what was the London Convention? What's the protocol? What actually was it, that thing that you just described?
I'm not, there's a colleague in the room who could far better answer that question than me. It is the convention basically that talks about the disposal of materials at sea and how we can best restrict the illegal dumping of waste materials and basically guide the best usage of the.
So putting things in the ocean.
It regulates all dumping of any material in the ocean. There are quite significant moves taking place in the US on this front in terms of the creation of at least models for regulatory frameworks that are more appropriate to this space. So that's something we can also look to. But I think we also have to differentiate between how you regulate an experiment and how you regulate something that you're planning to scale. Because you can't answer the questions to design the regulation without doing the experiment.
And this is, I think, one of the difficulties because, you know, on the scale of ocean experiment, you need to do sort of sprinkling a bit of dust in the little bit is not enough, that there's a problem that you can't, you actually have to start at a certain scale in order to get anywhere. Okay, so from Kathy in the audience, this is one for you, Elspeth. Practically speaking, how do you equitably involve local communities in these discussions and debates? Like if somebody in their area, or they work for a company, or they're a policymaker in a local area, and they're like, okay, here's the thing, I need to engage my community in this. What practically can I do?
Okay, so if you're thinking about, okay, I want to go ahead and do some marine CDR research, for example. So I mentioned already that there's definitely a need to involve the public or the community from the very start. So even in that point where you're choosing a site and checking whether it's suitable and you're scoping it out, that's kind of when you need to start thinking about bringing the public in. And you want to make this as inclusive as possible. So starting with perhaps groups, so having a small focus groups, seeing who the community leaders are, who the potentially affected industries might be, and also looking for those groups who perhaps are attached to oceans or do conservation, for example, and getting all the different voices in the room and trying to make that inclusive as possible. So that would be your starting point. So to get those initial voices in the room and then ask those, because they're from those communities, they've got perspectives to input into whatever the project is that you're developing, if there are other voices that are missing. And from that, you can also start to think about anticipatory workshops where you start to outline what potential risks, consequences, benefits could be and how people benefit from that. So that's kind of the starting point of where you would go, is looking for different voices within communities and potential stakeholders and making sure they're involved from the very start.
And just to ask, you know, I think one of the things that, you know, one of the attitudes that comes along when people talk, and I see this, you know, in the engineering faculty I work in, I sometimes see this, that, you know, engineers or physical scientists get an idea and then they're like, oh, here's my thing. Like you said, they kind of bolt on the social science bit. It doesn't actually ever occur to them that's a two-way process. So if in this example, you know, if there's a community that said, no, I hear your arguments, get lost. Basically, they are fully informed, they know their local area, they're perhaps enthusiastic, whatever it is, and they say no. Do they actually have any power in this debate? Or does this tend to still be a kind of rubber stamp? Oh, we did some community engagement, but we're going to do it anyway. Like, and maybe the others have something to comment on this. Like, how do we navigate this? Of course, we want community engagement, but there's only any point in doing it if you actually have a two-way process as a result of it, right? How does all of that work?
Yeah, I think that's really, really difficult because, I mean, if there's a red flag, for example, the public saying we don't want this in our area, that should really be respected and it should be stopped. Whether there's a mechanism in place to do that, I don't know what the governance around this isn't really there yet. I don't know if others have.
Well, I think any implementation would be dependent on permits, and permits can be issued by local authorities, it can be issued by national authorities, you know, or regulated internationally. So I think we need to sort of look at those mechanisms that are in place and start to align them with what could be seen as implementation strategies for different marine CDR routes. I think it's critical just on this topic to understand that, you know, communities will want to engage with this space because they have that different relationship in local communities, and we can't view all of these techniques that have been proposed as being applicable to all of the ocean, both, you know, scientifically, you know, from the way they work, but also socially. You know, although the ocean is 70% of the Earth's surface, you can't apply all these techniques over 70% of the Earth's surface because many countries will not want to see them implemented or do not have the capabilities to implement them because of the transportation of goods or materials. So we need to understand what those requirements are socially as well as scientifically as soon as possible, because then that will help us identify which are the potential winners in terms of this portfolio approach and really get a better sense on to what extent marine carbon dioxide removal can support global climatic targets.
Okay, so then there's another question here, which kind of follows on from the question I just chose to ask, which is how can academics promote the benefits of CDR efforts instead of raising fears and slowing deployment of sideline capital? What's the role of academics in this debate? Is there a natural caution within the academic community? Is it a justified caution? How much does it annoy people who are interested in capital?
From my perspective, you know, that academics are giving the monitoring reporting techniques, we're giving a lot of the scientific evidence and understanding. A lot of my students are being poached by companies, so they're giving them the scientific understanding. I think, you know, we have a relationship with the companies to generate the science, and I think we have to work in tandem. We can't isolate ourselves. We are not going to be the regulators of that. That has to be independent bodies, but we can help advance technologies and understand which are the most appropriate in terms of monitoring technologies. I think we have to find a solution. You know, we can't bury our head in the sand and say this is going to go away on its own. You know, we have to find the right solutions, and we have to be ready when that panic button gets hit, whether it's 2030, whether it's 2050, that we can give the best possible advice, and that will take years. You know, some of these processes, some of these natural processes take years to respond and actually start drawing down CO2 at the sort of potential scales we're talking of. So we need to be ready with that information when the time comes.
Well, I guess it's difficult. There's an interesting thing that I was thinking about today, which is that, you know, you can compare the planet to a sort of human body in a sense of you have, you know, obviously you want your surgeon ideally to have spent years and years at medical school and to have passed all their exams and to have done all the practices. But then if it comes a point where you need emergency surgery, how much expertise do they need to have before you let them have a go? And it's kind of that sort of thing. It's like, do you leave this person there to bleed to death or whatever it's going to happen to them? And there's an element about this, which is there's a time, you know, we need urgency, but then we have expertise we could develop. Like if you just let them go through another, I'd be far happier if they operated on my kidneys, if they'd just done another 10 lectures on what the kidneys do, you know.
But I think the challenge here is that if you leave all of this too late, it is literally too late.
Right.
Yeah. If you haven't done the groundwork forget about these particular techniques, any response to climate change, if you haven't done any technological response or even any natural recovery response, if you haven't done the groundwork ahead of time, in 10 years' time or 15 years' time, those options have been eliminated because it's too late to implement them at scale. You haven't got the knowledge and expertise to be able to do so.
Okay, so let's switch tack to quite an interesting, another can of worms. It's full of cans of worms, this. No idea what the carbon uptake of worms is. So governance, how do you approach the international nature of the oceans, this person has said. You know, and I guess the international nature of the oceans includes lots of things. There's what you do in your own if you do something on your own territorial waters, but the carbon uptake happens elsewhere, how does that count? If you obviously water moves around, it doesn't really respect the lines we've drawn in the ocean. The high seas is less regulated, should we say, and it's certainly less enforced. It's almost impossible to enforce anything that happens on the high seas. So you might write a regulation, but you know, they can do whatever they want out there, basically. How internationally, just when it comes to governance, how do we deal with borders and who's responsible for what and who owns that bit of water that's just inconveniently floated off down the coast? Go on, Rolf.
We have a step in the right direction in the biodiversity beyond areas of national jurisdiction, yet to be ratified as a treaty. But if it is ratified as a treaty, will at least get us to the point where there's recognition of the need to regulate the protection of biodiversity. And that's so closely linked to the climate issue. I think I'd reject your assertion that you can't police these things because
it's hard. In practice, it's hard.
But it is
expensive. Mostly it's expensive.
And you'd have to be able to do it. And I accept your point that the water's moving. So yeah, the areas you protect might not necessarily remain the areas you need to protect, but at least we've made a start.
Any other comments on international things? Okay, we're running a little bit. Have we got one more question in the room? Oh, we've got two at the back. Very brief questions, if you would.
Hi, Roberta from Counteract. I'm just wondering, just going back to MRV, considering kind of closed loop systems such as indirect ocean capture or direct ocean capture, however you want to call it, do you see kind of more focus being drawn towards kind of closed loop systems where the MRV is a lot more known and is a lot more secure? And do you think that closed loop systems provide more direct MRV? Because of course you can measure the amount of CO2 that's being drawn down in a kind of closed container as opposed to an open system like the ocean, so nature-based solutions.
Great, thanks. So let's start with the difference between open and closed systems. And who would like to just briefly say what those are? Go on, Chris. I think everyone's looking at Ross. Would you?
The different terminologies. I assume you're referring to the closed loop being electrochemical type approaches where you can directly monitor the extraction of CO2 from seawater versus the broader sphere. I think for me, the scalability becomes a question. You know, people are looking to the oceans because of the huge potential to use that vast percentage of their surface. You are not going to achieve that potential if you're just looking at closed loop systems. It could be that those closed loop systems are an initial route to use of the oceans because they are more can be regulated and accounted for in a more controlled manner. So this would naturally align to the use of coastal spaces for addition of alkalinity or other approaches as well. So I think that could be a stepping stone in the right direction. But again, look at this portfolio approach, you are not going to achieve the scales that IPCC type reports and national academies type reports are projecting, and why there's significant interest in the space. So to do that, you have to look at the integration of remote observations, potentially satellite-based observations, autonomous platforms, integration with models. We have, as a marine scientific community, the capabilities to do that. Again, it's in a question of to what degree, what precision is acceptable by the regulators.
Okay, right. I think there was a last question then. There was one more at the back. Very, very quick question and some hopefully quick answers. Yes.
Hi, Said Sane from Ice Data Surfaces. What my question was going to be about is regarding the actual emissions from the inputs, especially for methods such as ocean liming, given that lime is not an emissions-free material to get your hands on. If the emissions there outweigh the emissions sequestered, then surely the actual offset would lead to added emissions to the atmosphere.
Yeah, very good question. One of the many on the massive map of things we have not got to in this hour and a quarter.
So
Ralph, go on.
every single one of these techniques, you would have to look at the whole life emissions pathway to work out the efficiency that you're going to achieve. You can't just look at the end point of that. You've got to look at the whole chain. That has been done to a degree for some of these techniques, to at least make sure that the emissions of the process are not greater than the emissions that you're ultimately going to be removing from the atmosphere.
Yeah, so the life cycle analysis, techno-economic analysis is a critical area of research needs for marine CDR approaches. It's something we're looking at, but more work needs to be done in this space. On ocean liming in particular, I just want to flag there's been a recent best practices guide in ocean alkalinity enhancement, which actually delves into some of that as well. I think building in with this life cycle assessment, you can't just think of ocean CDRs all happening in the oceans. There will be a land footprint, whether that's energy, whether it's provision of materials, whether it's ports and docking and humans, it's all connected. And we've got to consider all of that in terms of the implementation potential and community engagement as well.
Okay, we are pretty much out of time. I just wanted to ask very quickly, and I didn't give you notice of this question, so feel free not to, if you haven't got an immediate answer, but are there any particularly good resources that you would recommend, or any big things coming up or questions that people should be paying attention to in this space? So resources, things to look at, where can people find out more? Any suggestions? Oh, Elspeth, you got
So last week, I've written it down so I've remembered the name for it. The Aspen Institute released a code of conduct for marine CDR research. So it's quite a detailed document. and it covers all aspects. So it's kind of outlines principles that you could apply socially. So they're kind of philosophical principles, but it's a really good guide for anybody to have a look at. And there's lots of resources in there, links to papers for public engagement or questions around other aspects too. So that's one I would mention.
Brilliant.
And Ocean Visions, as an umbrella organization covering this area, has published a number of roadmaps covering each of the different techniques that were shown on that slide, and most recently have published a roadmap for evaluating the efficacy of each of these techniques. So what steps do we need to go through to achieve that?
In terms of research needs, there's the best practice guide to ocean alkalinity research was one example, but there's also the National Academies of Science and Medicine in the US have published a report a couple of years ago now, which outlines the research requirements for this space. And more broadly, the Hub led on the production of the State of CDR report, which is a really good go-to for the broader need for carbon dioxide removal and where we currently are, where we're currently not at in terms of our requirements for meeting some of the government's projections.
Brilliant. Anything to add? All good with that? Okay, right. In which case, there will be a reception through that door, so you can all continue the debates and ask all the questions that you didn't get a chance to ask. But before you toddle through there, please, first of all, we should say thank you to CORE and to the Royal Society for hosting us. I hope that we've given you some food for thought, and that you're equipped with a few more good questions to ask when these topics come up in the future. And please join me in thanking our 4 fabulous panelists, Ralph, Chris, Ros, and Elspeth. And do move on next door, and we will see you in there. Thank you.